So there's only one objective, what we're trying to get out of doing today. And it's calculator-based. It's the kind of thing that if I could, I would send you home with a calculator and you'd have homework on it. But we can't do that because we don't get to issue you calculators. So instead, we'll just have to do some practice in class, right? And then we'll have our quiz over the first part of the chapter. The specific learning intention from the SOLs, I mean, includes some other things in there, but basically when it says find the zeros algebraically or graphically, we are finding the zeros now graphically with the calculator. We kind of already know how to do this a little bit, but you're going to see the part of it that we don't know, and you'll learn how to do that. Okay, first of all, I'm trying to remember. Just to review again, these are the 4 shapes that we've dealt with, right? There's more, like we had quintic and you can go 6 degree, whatever. But the basic ones that we deal with in this, because the calculator only models this much, are linear, quadratic, cubic, and quartic. Okay, remember, linear, right? When the slope is positive, it looks like this. When the slope is negative, it looks like that. Quadratics, when the A, the leading coefficient, is positive, that means it opens up. If it's negative, it opens down. Right? Cubic, if the first term is positive, it would have this shape, right? It would have end behavior, which was down and then up. But if the leading term was negative, it would be up and then down, right? And quartic, right, could have up to 3 turning points. And if it's positive, it would be up and up. If it's negative, it would be down and down. Remember, the number of turning points you expect in a polynomial, it's always 1 less than the degree. At most, 1 less than the degree. It could be even less than that, but it can't be more than that number. And the important thing about these graphs of polynomials, relatively important, is graphs of polynomials are always smooth and there's no breaks. So what you call, in math terms, you call it continuous. Smooth and continuous. No sharp points on it or anything like that. No breaks in the graph. Because I can't send you home with the calculator, right, to do what we're going to do in class today, I'm going to assign a little bit of homework that does go back to this. And that's pretty much all you need to know right there. Or at least for that part of the homework. And again, just to remind ourselves, that's what a cubic looks like. And how many zeros do you see on that graph? You see 3, right? It could have it has 3 complex zeros, and it just depends on, where is it relative to the x-axis, right? It could have 1, or it could have 3. It would have 1 if the x-axis was down there. Could it ever have 0? No, because the graph goes forever down and forever up. It's always going to have 1, right? If it has 1 real 0, which is what you see right there, how many imaginary does it have? Remember what we just said. It has 3 total, and 1 is real, so the other 2 are imaginary. If you have a quart, how many zeros do you see on that? I mean, that's clearly a quartic. We recognize the shape. It has 4 real zeros. But it would be possible for this thing, right, to only have 2. Right, there's 2 zeros instead. It would even be possible for that whole thing to be not cross the x-axis. Now it has none. Right, so how many imaginary zeros does it have if that's the shape of the graph? It has 4, right? How many imaginary zeros does it have if it's like that? 0, because they're all real. They're all on the x-axis. Those are real zeros, which is the only thing we're trying to find today, right? We're not going to find any imaginary. And then how many imaginary zeros does it have if it looks like that? 2, right? It says 2 real, so the other 2 must be imaginary because there's a total of 4. Okay, so solving by graphing. Remember, when we graph a function, if we want to look for the zeros, where do we look on the graph? Right, remember, because on the x-axis, right, this is the x-axis. Yeah, on the x-axis, y equals 0. So if you want to find the values of x that make y equal 0, look for these points right here. And what does it look like the zeros are on that graph? Negative 2, 2, 1, 2, 3, 4, 5, 6, right? Okay, so there's a 0 equal, the zeros are negative 2, 2, and 6, right? But what do you reckon? First of all, it's a fourth degree polynomial. So how many zeros do you expect this to have? How many complex zeros? It has to have 4. How many real zeros does it look like it has? Okay, well, how many imaginary would it have then? How many imaginary would it have? Can it have one imaginary zero? I will be talking to the nurse, okay? Okay, so what's wrong with that equation? If you had 3 real zeros, then we make 1 imaginary, but what do you notice because of that right there? That's actually 2, right? That's what it looks like when a 0 is coming from a factor. Remember, the factors of this thing must be, right? This one would be an x plus 2, right? This would be an x minus 2. This would be an x minus 6, right? But when you see that the graph actually touches the 0 and goes back in the same way, then that means it must be squared. So it's actually 2 zeros. They're the same thing. But what do you call that again? We had an M word for that. Multiplicity 2, right? So you could say this one is, just this one, right, is multiplicity 2. Okay, now, how else could you confirm that? If you were looking at that graph and you thought it was negative 2 and 2 and 6, how could you confirm that with the calculator? Just look at the table of values, right? You would expect y equals 0, and then the x values would tell you. And that one was correct. Those are the zeros. Okay, but it's not always like that. And that's what we have to figure out. How do you find the zeros that don't just show up in the table of values? Ready? Okay. We ready? All right, so this function here is a cubic. How many complex zeros should it have? It could have 3. Looking at the graph, how many of those zeros are real? Look again. 1, 2, 3, right? So, and you know, the way this one looks, it looks like it's negative 1 and positive 1 and positive 4, right? So you go to your table of values and you look, and are any of those actually zeros? Do you see any y equals 0 here? No, not a one of those is a 0, right? So we have to learn, well, how can I find what the 0 actually is if it doesn't happen to be one of these integer values which automatically shows up in your table of values? So, and now notice it looks like this 0, right? This one right here is around negative 1. If I look in the table of values, notice what's going on. At negative 2, the value of the function was negative 17, which means it's below, right? And at negative 1, the value of the function was 1, which means it's above. So where's the 0? It's got to be in between negative 2 and negative 1, right? Somewhere in the middle of that, it turned from a negative number to a positive number. It crossed the x-axis. So you can find your zeros by looking in the table of values, right? It's somewhere between negative 17 and 1, so between negative 2 and negative 1. There's 1 in there. Where else is there a 0? Just based on the change in sign of y. Between, there it goes from 1 to negative 5. So in between 1 and 2, it must have crossed, in between 1 and 2, it crossed the x-axis again. That's the second 0. Where's the third 0? It looks like it's around 4, but can you see in more detail? Is it greater than 4 or less than 4? It's between 3 and 4, right? Because there the y is negative 7 and there the y is 1. It crossed the x-axis somewhere in between those two. So there's 3 zeros in the graph. They just don't happen to be at those nice whole number values that we're used to. So I'm gonna show you these calculator procedures for finding zeros. And you need to be trying to follow along, right? If you don't follow along, there's nothing I can do to help you, right? I'm gonna lead a horse to water, you can't make him drink, okay? As they say. So in this problem, you're going to start out in the calculator, put that function on the y equals, right? There it is right there. Put it up there. That's the starting point. Good? Okay, next step. Okay, we're going to hit second trace, right? There's the trace key right there. If you hit second trace, it's actually doing the thing which is right above the trace key. What does it say? It says calc, right? And the thing is that when we did the modeling data, we would go stat calc. That's a different calc, right? That was under the stat menu at the top. This is second trace gets you to this calculate menu. And then you can see the number 2 option there, 0. That's what's going to find our zeros for us. Second trace 2 for 0. So hit that. Okay, and from there, so you should have a screen that looks like that, right? It says left bound. So here's the thing. How many zeros do we have to find here? You have to find 3 zeros. You have to find them one at a time, right? You focus on 1 zero at a time. Okay, so I circled this one because I'm going to look for that one. That was the one that we saw in the table of values. It's somewhere between -2 and -1. So I'm actually going to make use of the table of values for this reason. Although you really don't have to, I'm going to use it for that reason. Okay, so when it says left bound, it's expecting you to enter an x value which is less than the 0. So looking at the graph there, you know, it looks like it's around -1. If we just use the table of values, we know that this -2 is less than the 0, right? It's in between -2 and -1. So let's use -2 as our left bound, right? So enter -2 and then hit enter. Right? When you do that, are we okay with that? Did you hit -2, enter? You're going to see a screen that says right bound. Okay? It wants an x value which is more than the 0. So again, since we're looking for this one particular 0, I'm going to use -1 because in my table of values, I confirm that is to the right of the 0, right? It's in between those two. So hit -1, and then enter. So the left bound was -2, the right bound was -1. When you hit enter again, what does it say? It says guess. Where am I at? It says guess, right? And what you'll notice is it put 2 triangles where you put your left bound and your right bound, right? And it's asking, do you want it to calculator to calculate this thing in between those 2 arrows? You always say yes. I mean, you presume that you put them where you want it. Just say yes. Hit enter. Just hit enter and see what you get. It should have done this thing here. The cursor should have gone right to the 0. And it says it right there, 0, x equals, and of course it's on the x-axis, y equals 0. Yeah. Okay. If you want to copy that. You good? Gotta go? What is that? Okay, we uncopying that if you wanted to? I'm just saying, if we're done copying, I'll go to the next slide. If we're not, we'll wait. While you're finishing copying that, I'll just say that when it says left bound, right, you don't have to use the table of values to do that. You could pick any X value you see on the screen there that's left to the left of, which means less than on a number line. So like if the 0 is there, I mean, I could have picked something like -5. It's far away from there. No problem. Just put in -5 and hit enter. And then for the right bound, you know, there's our 0. Put in something that's to the right, but not to the right of any other zeros, because you don't want to confuse the calculator. So maybe I'll put X equals 0 right in the middle of the graph. And then when you say guess, it's still going to go to the same place. Right? So I'm using the table of values because the table of values will definitely won't have any issues with like putting our right bound or left bound too far away. And the other thing, you could do it like this, which I'd say is the way most students do it, is like this. They go second, trace, 2 for 0. And for the left bound, they actually use the arrow keys and just move the cursor to the left, like this. So when I move that cursor down below, it's actually a little bit to the left too. So I hit enter, and then I move it with a right arrow until it's a little bit above and a little bit to the right, and then I hit enter. Same thing. I mean, I'm using the table of values just because it may be an easier way to get the precise numbers you want to put in. Now, you don't want to put -40 because it's not on the screen. The calculator won't know what to do with it. You got to put a number which is on the screen right in front of you. Okay. So did we get our 0 of -1.093? You know. So then we have to find the other two zeros. Right, so now we're going to find the middle 0. Again, that middle 0 is in between which two X values? 1 and 2. Right? There's the change of sign happens between X equals 1 and X equals 2. So your left bound will be 1, your right bound will be 2. Try that. Right? So go second. Remember, you're starting all over again. Second, trace 2. And then for the left bound, put in 1. For the right bound, put in 2. And then guess. Just hit enter. Zoom 6. You could probably turn off the PowerPoints, but okay. Let's see. Second, let's see your graph. Graph 1. Okay. Graph. Zoom 6. So there's your graph. Now try it. Second, trace 2. Put in 1 for the left bound. Enter. 2 for the right bound. Enter. And guess. Enter. Enter. Done. Yep. So were we able to get an answer? 1.163 approximately? every x-intercept, right? Okay, so we have to do it one more time, right? We got to find that third 0. Let's go for that one. What do you use as left bound and right bound? Three and 4, right? Because you can see it changes sign between 3 and 4. The 0's in there somewhere. So go through the same steps. Second trace 2. Left bound 3, enter. Right bound 4, enter. Guess, enter. Who needs help with that? Christian. I told you 3 and 4. Okay, I'm sitting there telling you in the table of values, right? If you look, you can see that this graph is changing sign. The y value is negative there, it's positive there. That means it had to have crossed the x-axis somewhere in the middle. So go ahead and use for your left bound, use 3, and for the right bound, use 4. Okay? What's the answer on that one? 3.930. Okay. I'm going to assign just like 3 classwork problems just to work on that I'll get a chance to go around and help those who need it. But it should have been 3.930, right? And you should see it right there. Now because some of you know a little bit about the calculator already, are maybe in the habit of not hitting second trace, but you just hit trace, right? If I go to the calculator and say trace, right, that puts the cursor on the graph. And then maybe you can move it to the left or the right and you get close to 0. But it's not going to be exactly y equals 0. That's not good enough. You have to do the second trace for calc and then do 2. Right? Just by hitting the trace button gets you close. It does not get you exactly there. Okay. So we're going to try these 3 in the book. And remember what we're finding here when we do this. We're finding the real zeros, right? Not the imaginary. Real zeros show up as x-intercepts. Those are the only ones we can do this with. So 301, I'll put it up on the screen. And that is the end of what we're doing today. I'll write the homework on a different slide. I'm going to put the textbook picture of these problems for those who don't have the textbook with them. I asked for that worksheet. Where's the worksheet? Okay, partial. Okay. Okay. So there's the 25, 27, and 29. See if you can find the real zeros using these procedures. And that is the end.